Good day, viewers. Welcome back to Networking E10. A note to all my viewers, the videos which I am sharing on this channel are for breaking down networking concepts in its simplest form, which will benefit viewers who want to understand networking. Let's begin. In the previous video, we understood what is networking, why are networks required, and moreover, we understood usage of networks. That being said, in today's discussion, we will try to understand 1. Why we need networking model. 2. Need for OSI model and TCP IP model. 3. Layer-to-layer comparison of OSI model versus TCP IP model. 4. Functions of the 7 layers of the OSI model. And 5. 4 layers of the TCP IP model. Now that we have understood the significance of networking, next we need to understand the basis of data transmission. We, as human beings, understand data in the form of text, images, audio, video. For example, accessing the websites which are in the format of text and images. Another example would be to make or receive video calls or audio calls. On the other hand, physical transmission mediums like local area network, Wi-Fi, optical fiber cable only transmit data which is in the form of digital ones and zero S. They are transmitted in the form signals over the wire or in wireless form. Listen to this carefully now. If we want to transmit data from one network device to another network device, two objectives need to be satisfied that is transforming data from human-readable format to machine-readable format that is text, image, audio, video format needs to be transformed into digital bits of ones and zeros, and then transmit those ones and zeros over the physical medium in the form of signals, which is eventually connected to the networking device on the other end of the network. In order to achieve this objective, there was a need for laying down a framework, and moreover, it had to be standardized and accepted by all the networking device vendors and stakeholders. The answer to this was to have a so-called network model, which would lay down a set of guidelines for data transmission. This led to the formation of multiple competing vendor proprietary network models. It could not be used for interconnecting networking devices which were manufactured by different vendors. This meant that only specific vendors could become market leaders and have a competitive edge. For example, take a look at Bobby's network, which is not open for standardization since he strives to become a market leader. Alternatively, in the 1970s, the International Organization for Standardization, also known as ISO, took on the task of creating a new network model which was known as Open System Interconnection Network Model. It is also known as the OSI model. The primary goal of this model was to standardize networking protocols to allow communication between computers across the entire planet. For example, take a look at Smith's network, where two networks are planning to use OSI model since they share the same vision. Another competing networking model sprouted forth from the US Department of Defense, which came to be known as TCP/IP model. It had aimed for development with standardization, but with less formal approach. By the late 1980s, the world had many competing vendor proprietary networking models plus two competing standardized networking models. So what happened? OSI model suffered in part because of slower formal standardization process as compared to TCP/IP. Vendor proprietary network models usage dropped in comparison with TCP/IP. In the end, it was TCP/IP model which became popular and widely accepted and continues to be the same today as well. This brings us to the point that we need to understand TCP/IP model in depth. To understand TCP/IP network model in depth, we need to grasp OSI model because the roots of TCP/IP network model are derived from OSI model. This brings us to the 7 layers of the OSI model. Just to recap once again, for data transmission to happen, human-readable data format data needs to be translated to digital bits of ones and zeros and subsequently transmitted over the wired or wireless physical medium. Let's see how the OSI model achieves this by understanding the function of each of the 7 layers. Note that that 7th layer is application layer all the way down to the first layer, which is known as the physical layer. 1. Application layer provides a user interface which allows humans to input data. For example, humans input data into computer or smartphone. 2. Presentation layer is responsible for data translation, which means data from application layer needs to be translated to standard format. For example, data needs to be translated from ACI format, that is American Standard Code for Information Interchange format, to EBCDIC format, that is Extended Binary Code Decimal Interchange Code format. This layer is also responsible for data encryption and decryption, compression, decompression, and syntax-related operations. 3. Session layer is responsible for dialog control. It also keeps different application data separate from other application data. 4. Transport layer is responsible for data segmentation, provides reliable or unreliable delivery, error control mechanism, and flow control. 5. Network layer is responsible for maintaining IP addresses and routing of packets from one network to another network. 6. Data link layer formats the message received from network layer into data frames by inserting hardware address of source machine and destination machine. 7. Physical layer is responsible for translating the data received in the form of ones and 0s into electrical, optical, or radio signals, and then transmit it over the wired or wireless physical transmission medium. Now that we have understood each of the 7 layers of the OSI model, we would easily understand the TCP/IP model, which would be the basis for our future videos. As you would see, there are 4 layers in TCP/IP model, namely application, transport, internet, and network access layer. If you compare both the layers, you would see that the 3 layers of the OSI model, namely Layer 7, Layer 6, and Layer 5, are combined into a single Layer 4 of the OSI model. Transport layer remains the same for both the layers. Network layer in OSI is named as Internet layer in TCP/IP model. Data link layer and physical layer of OSI are combined into single layer known as Network access layer in TCP/IP model. Additionally, I want you to view the Protocols and Devices column. These columns convey important information, namely the protocols used for each layer, along with devices used at the respective layer. That helps us to interlink each layer of the TCP/IP model with the protocol and the devices used in the real world. Please note that though we know that TCP/IP model will be the basis for our future videos, we cannot completely ignore the OSI model. The reason for that is purely because TCP/IP model was inherited from the OSI model. We will not understand the TCP/IP model until we understand each of the 7 layers of the OSI model. Thank you for watching. Be sure to like, share, and subscribe, and I'll see you in the next video.